Hi all, it's me again and my name is Kashish and I'm going to be explaining question 2 for EL6303 homework 2. So this is our question. We have been given a noisy channel and it takes input xk and gives output xk plus 1. The information that we've been given is probability that input is equal to 0 is 0.2, probability that input is equal to 1 is 0.8, and then other than that we are given 4 conditional probabilities right there. The first conditional probability out here, this one, reads given that input is equal to 0, the output will be equal to 0 has a probability of 0.6. The second one next to it reads given that input is equal to 0, the output is equal to 1 will be probability 0.4. And similarly the other two read. Now these 6 values can be diagrammatically represented as this. So given that input is equal to 0, the probability of getting an output 0 is 0.6. Given that input is equal to 0, the probability of getting an output 1 is 0.4. Given that input is equal to 1, the probability of getting an output 0 is 0.3. And given that input is equal to 1, the probability of getting an output 1 is equal to 0.7. Also, the probability that input is 0 without any condition is 0.2, and probability that input is 1 without any condition is 0.8. Our first question is find probability x of 2 is equal to 1. So for this, consider x to be equal to 1 and consider k to be equal to 1 and put this value of k in these 4 equations given here. Once you put the value of k in these 4 equations given there, you will get probability of x of 1 equal to 0 given and thus output x of 2 is equal to 0 will be 0.6. Probability given that x of 1 is equal to 1, giving an output of x of 2 is equal to 0 is 0.3, and similarly these two. Using the formula of total probability, using the formula of total probability, probability of x2 equal to 1 is equal to probability of x1 equal to 0 into probability of given x1 equal to 1, output x2 equal to 0 plus probability x1 equal to 1 into probability given that x1 is equal to 1, the output will be equal to 1. So that is 0.2 into 0.4 plus 0.8 into 0.7, which gives you 0.64. Now, we know that probability x2 is equal to 1 is equal to 0.64. Therefore, probability x2 is equal to 0 will be 1 minus 0.64, which will be 0.36. This we need for our next question, the B part. The B part is find probability x3 is equal to 1. So again, consider k is equal to 2 and put this value of k in the question. Once you put this value of k in the question, you will get these two equations which read, given the probability that x2 input is equal to 0, the output is equal to 1 is 0.4. Given the probability that x2 input is equal to 1, the output x3 is equal to 1 is 0.7. Again, using the formula of total probability, which is probability that x3 is equal to 1 is equal to probability x2 equal to 0 into probability given that input is equal to 0, output is equal to 1, plus probability x2 equal to 1 given into probability given that input is equal to 1, output is equal to 1. When you put these values in here, 0.36 into 0.4 plus 0.64 into 0.7, you will get 0.592. So that is the second part. The third part of this problem is find the probability given that input is equal to 1. Find the probability given that x3 is equal to 1 and x1 is equal to 0. x3 would basically at any point in time be the output for x2 being the input, and x1 would be the input for x2 being the output. So we have to find the probability that that x3 given that it's given that x3 is equal to 1. What is the probability that x1 must have been 0? So to find this conditional probability, we simply use the formula of conditional probability, which is PA given M is equal to PAM upon PM. So, assuming that x1 is equal to 0 and x3 is equal to 1 are mutually exclusive, we can write P of A intersection M as P of A plus P of M. So that's P of x1 is equal to 0 plus P of x3 is equal to 1, and we know both of these values, divided by P of M, and M here is x3 is equal to 1. So inserting the values which we already know, we get the answer of this conditional probability as 1.337. So that's about it. These were parts A, B, C of problem 2, homework 2 for EL6303. Thank you.